Hello everyone, welcome to the webinar regarding API 6 introduction. We'll be starting in about 2 to 3 minutes. I just would like to get your feedback. How is your video doing and how is the audio doing? Whether you can hear me well and see me well. Okay, thanks for the feedback. It seems that for most of the public, it seems to work fine. We'll start. We have roughly 70 participants, so I don't want to keep your time, and let's get to it. My name is Pavel Sodomka. I am the co-owner of the group of Sigfox operators in Central and Eastern Europe, and I am the CEO and the founder of the Simple Hardware, where we try to produce cheap and reliable and well broadcasting Sigfox devices. So the theme of this webinar is about API 6 and how is it revolutionary? Why do we think it's revolutionary? It's basically intended for system integrators, SOs, IoT platforms. The technical level is intermediate, so we will not be going into very, very deep details. More details are available online, or you can ask during the chat, so we can drill down more deeply. But it will be also not superficial, so it's not for salespeople, but it's more for integrators. The presentation should take about 30 minutes. I have about 25 slides, I think, now, and a large portion should be Q&A. So why API 6? The first for the number. Our first API for SimplePack 1.0 was called API 2. Then we had API 4 for SimplePack 1.1, and we had API 5 for SimplePack 5 for SimplePack 2.0. And when we decided that we will be redoing the architecture, migrating from microchip and YSOL to SD micro solution, so we also decided, as we are adding more and more sensors, that we need to redefine completely the API 6. So the API 6 is not backwards compatible to API 5. It's also not completely API. We call it API, but basically it's a description how you control the devices, how you interpret the messages, and how you communicate, how the devices communicate between Sigfox backend, IoT platforms, and the device itself. You know that there's a major limitation of Sigfox, which is 12 bytes in upload and 8 bytes in download. So no IP format support, no REST API. When you traditionally communicate with the device or parse the messages, you have a lot of metadata around it, and you have a lot of comfort what to do with the device. But Sigfox is by design limited to this 12 bytes and 8 bytes. Which is, I think, for some of the purposes, it's a pity. On the other side, it gives us a lot of pressure to think smart and to do things smart way and to save data, because basically we think that IoT needs smart devices. It's similar to the human body, where your human sensors are not overwhelming the nervous system and not brain with information all the time, but sends only relevant information to the brain. So the same stuff should apply for IoT sensors, where IoT sensors collect, processes, and send information only on time and in relevant events. There is documentation about our devices and API 6 available. Everything is available at ask.simplehardware.eu. There's an API 6 table. We are still working on the documentation, so it's not perfect. And basically, this webinar is also part of the documentation. But it's rather complex. The API 6 is rather complex. covering tens of sensors, covering tens of business cases. So therefore, the documentation is not finished, but we are diligently working on it, and we hope to update it all the time. Also, any kind of feedback from your side is, of course, welcomed and appreciated. So when we define the API currently Sigfox doesn't propose or doesn't do any standardization regarding the payloads of the devices. Basically, Sigfox works as a VPN, as a virtual private network, just connecting the devices to the backend, and they don't have any recommendation regarding the compression or data formats, maybe with the exception of the Wi-Fi Atlas, but they are really agnostic regarding the payload. And we are tackling basically 4 major issues. One is data interpretation, so it means how you process and how you understand the data the devices are gathering and are communicating. The other is how to control the business logic on the devices, because when you have 8 bytes of downlink, you cannot do any kind of long workflow programming. You cannot send down the code to the device, do this and this and this precisely. So you need to find ways around it. And then, as you are also limited by the bytes, so you need to use some smart data coding and compression. So you cannot use UTC format for time. You cannot use like full-featured formatting for temperature, and we'll show you how we tackled that one. And the last one, not the least one, is the device control. Basically, how to control the device, how to configure the device using just 8 bytes. So let's get to the first one. How we do it. What we have seen from the last APIs, from the previous APIs, it's quite important for the IoT platform or for any kind of interpretation that it understands which mode the device is at. So we are always reserving the first byte of any uplink message for the mode or business logic that the device is at, and we are using the second byte where we are sending a predefined type of event. So being it press button, temperature overreach, movement, start of arming, heartbeat. Those are all the events that the device can trigger and can send. They are predefined in the table, and we are using the second byte for it. And then, depending on the mode, we are using either appended payload. So we are able, for each of those messages, we are able to append some kind of information, being it current temperature, current voltage, current position, current magnetometer values. Or when the mode needs to use the full payload, we are using 10 bytes as mode-specific data. So, for instance, when you have the monitor me mode, we are just telling this is the monitor me mode. This is the event that was like the last movement, and then the whole pipeline of all the messages that are in the pipeline. So you cannot have, for some of the modes, you cannot have the appended payload. You can have for some of the events you cannot have appended payloads. Again, it's described in the API 6 table, and it's available there. So probably the most simplest example is how the data looks in the backend. That when you have the device in the press me mode, so the mode that the devices are shipping with, it looks like 10, this is the first byte, which tells us that it's in the press me mode, and 30, which is the press me event. So basically, it's a hex. Everything is hex. So 30 is the press me event. Press me event in the press me mode. Then, if you have the temperature monitoring with pipeline, That's the example of the payload where we are using where we are not using the appended payload, but where we are using the mode-specific data. So you can see that 11 it's the temperature monitoring, 85 it's the temperature alert, and then we are sending always like a double of data, where we are sending time together with the latest temperature. So the pipeline is basically a redundancy, where we are able to send through one message. We are able to send multiple temperatures within some kind of time frame. Then for the appended payload, basically it can be added for any events that is numbered from 1 to 128. It can be also appended to our 2 heartbeats. And it's important to understand that always with the appended payload, the first byte is used as a mask for interpretation. So because what we wanted to achieve is that any kind of IoT platform doesn't need to keep the status, the state of the device with it, and can interpret the data only through the payload. So we will basically tell the platform what kind of data is going to follow, and this mask tells us what kind of payload is going to follow. And you can append voltage, temperature, accelerometer, magnetometer, MAC address, and Boolean values like read contact, light contact on off, and humidity. And here is the example. Again, we are in the press me mode, which is the first byte 01. You have the press button 30. Then you have the 40. That's the mask, which tells us the temperature is going to follow, and 67 is the coding for the temperature, which is currently 76, is minus 18 degrees Celsius. So in this way, you can append a lot of information to any event that happens on the device. For the data interpretation, where we are using the fixed position, and sometimes it seems that we are using too much bytes, at least the first 2 bytes. It's because we want the basic events to be really human readable. If you see it in the backend, so you always know that you can very easily tell which mode the device is at and what kind of event it is. The stateless data interpretation is quite important, so you don't need to keep the data on the state of the device on the platform. And you have also clearly predefined events for the further processing. So when you have an event like start of movement is in all the modes, in all the business logic is the start of movement. The same with heartbeat, the same with temperatures, with any kinds of events. So for any kind of workflow processing on the backend, it's a big advantage, because then you can do the workflows pretty easily. And we're also trying to have the payload as small as possible. Okay, there's a colleague walking. So next slide. We have couple of exceptions. Of course, any rules needs exceptions. So we have 2 modes that were programmed recently on the demand of some of the clients. We call it stupid mode 1. When one client requested sending basically only 2 MAC addresses at predefined time for localization. So we are using this one, and we are not using the classical format. Then we have the stupid mode 2. I missed a typo here. Stupid mode 2, where we are sending null payload. So we are just sending the Sigfox header 0 payload at predefined time for localization. It's specifically for Sigfox Atlas localization. Then the exception is also sending Wi-Fi Atlas modes, because with Wi-Fi Atlas, you are sending 2 MAC addresses. The issue is that the MAC address is 6 byte and it's not compressible. So basically, you have no way how to tag that the Sigfox Atlas message is coming. Therefore, we are using two messages. One message is just telling you the next message will be Wi-Fi Atlas, and it's also sending you the type of event that triggered the sending of the Wi-Fi Atlas, and then the Wi-Fi Atlas follows, and there's like always either Wi-Fi. So when the system wants to use Wi-Fi Atlas, we have also a precursor, basically message that tells you, be aware the Wi-Fi Atlas is coming. We have also one thing is that we are reserving some of the modes in such a way that any kind of interpreter shouldn't be confused by processing the MAC addresses. We can, if there would be any more questions, we can explain that. But it's pretty stable system. And then we have an exception with monitor me, where when you change the interval of monitoring me, so when you change the interval of monitoring of the chairs or of an engine, we are not sending this interval together with the message. So you need to keep this information. If you change it from the default values, you need to keep this information in the system in order to interpret the data properly. So those are the 4 exceptions to the general rules. Then, so that's the first one. So that's the data interpretation. The second issue is how to get the business logic to the devices, because again, we are pretty convinced that the devices needs to be smart, that an IoT device is, for me, a temperature meter which is sending a temperature each minute, it's not an IoT device. It's just a stupid device. So I really prefer to have smart devices that, for instance, send temperature only when there's a change in temperature. It doesn't make sense to send the data all the time. Just very briefly, I have a question here, whether the stupid mode message is the same as second message of Wi-Fi Atlas mode. And yes, the stupid mode message is the same format as the second message of Wi-Fi Atlas mode. Is the same format. Basically, it's just to MAC addresses. There's a bit manipulation on the 7 and 8 bit of the first byte, but otherwise it's just 2 pure MAC addresses. So it's the same from the interpretation point of view. And why Sigfox needs smart devices? Because of this limitation. So with Sigfox, we are not only limited by the length of the message, but also by the number of messages. So you cannot send thousands of messages. You cannot send thousands of downlinks to the device. So the device needs to have a little bit of logic on its side. Basically, again, as your senses, your senses are also sending whether the finger is freezing only when the finger is freezing, and not sending temperature to the brain all the time. And of course, the battery life, when you are sending a temperature each minute, you drain a lot of battery. When you send only the changes or the relevant information, you save the battery. So what is a mode? Basically, a mode is a combination of what is measured, when, and for how long. So for instance, it's a combination of whether you measure temperature, when do you measure temperature, and for how long you measure the temperature. Then you evaluate the measurement, for instance, whether the temperature has changed anyhow, and then you tell the device what is sent and when it should be sent. So whether the temperature change should be changed immediately, or whether it should be recorded in the pipeline and send it with other messages. So it's a combination of business logic. Basically, think about a mode as a separate device. So currently we have about 60 modes programmed in the latest firmware. So think it as a completely separate device, just sharing the same hardware. What's important is that modes are crucial or very important for integrators, but customers should never switch between different modes. So they shouldn't have the ability to device to be 1 minute a tracking device and a door sensor device and then I don't know, a push button. It's for the end customer. The end customer should always be fixed to just a single mode and not to switch among different modes. Just a question on the slides. The slides and recording will be available. The slides will be immediately available just after the recording. So everything the same way as we did it in the last webinar. The slides and recording will be available the minute that we finish, both on YouTube and on our website, SimpleHW. So examples of modes. The classical one is the press me. Then we have the trace me mode, which is the mode where we are sending messages only when the object is moving, and we are not sending any messages when the object is not moving. The monitor me mode is the typical mode for engine monitoring or office chair monitoring, where you are sensing vibration, recording the vibration, compressing the payload and sending it each 40 minutes to the backend, where you can do the decomposing of the message and you can calculate the time of movement to the precision of 1 second. So it's a very precise mode. We have, for instance, the put me back, which was developed mostly for dustbin emptying. So, for instance, this mode starts to sense when the object starts to move. Then it measures for as long as the object is moving. When the object, basically, the empty bin is being manipulated, it's being turned over, it's measuring all the accelerations. And then when it's in the still, when it's being put back. So we are sending in the payload, we are sending information of the current accelerometer, so you can tell whether the dustbin is in correct position. Plus, we are sending the min and max values, so you know whether the dustbin was really whether it was really empty, whether it was turned upside down. So those are the examples of the business logic of the different modes, and we have, as I said, we have 55 more documented. Again, if you would need to have an advice, don't hesitate to contact us either through chat or through the ticket with your concrete use case, and we will help you to choose the correct mode. I would just show you Tomáš Poláček, who is our CTO and one of the inventors of the API 6. So it's a lot of basic is in his invention. So I'm glad that he is with us and working on in R&D on the future project, just finishing the checkboxes. So Tomáš Poláček, thanks to him, we were able to use API 6.
Good luck.
So more modes are added to the API 6 on the customer request. We are a little bit. We are a little bit. Currently, we think we have enough modes. So, but again, when new requests are coming, we'll be most probably releasing a new one, some new ones within 6 or 8 weeks. So we'll be slowing down the release cycle, basically. The examples of the newly added modes is the Wi-Fi high precision mode that was done for one of the Sigfox operators, where we are basically recording the Wi-Fi MAC addresses into the device and sending only the pointers of the Wi-Fi MAC addresses, meaning by one message you can send 5 MAC addresses together with the RSSI, with those 6 signal strengths. And due to fingerprinting, you are able to achieve 1 to 2, 3 meter precision accuracy just using Wi-Fi and Wi-Fi beacons, not having to use bubble or having to use Bluetooth beacons or RFIDs. Then we have added a read counter mode. Of course, you can use it for instance, for your bike, if you put the SimplePack on or if you put the magnet on your bike, and plus the SimplePack, so you can measure the number of turns of your wheel. But this one was developed for door opening, so they wanted to know precisely how many times the door got opened within 1 hour or within a day. And the last one that we have implemented was a blink till switched off. So basically, someone presses the button, it blinks, and until you press it again. So those are the examples of modes that we have added recently. So then we have we have some slides about the data coding and compression. We are using basically 2 of them are unique, 1 is not so unique. We are using coding for time. We're just using 1 byte. You can define time from between 1 second and 63 days. You may be asking how we do it. I'll show it in the next slide. Then we are using coding for temperature, where we are coding for values between -40 to basically 90 degrees Celsius with ½ degree precision. We could be expanding on that coding of temperature when the precision, or basically not precision, the resolution needs to be higher. We'll see this can be developed further. And then for voltage, we are able to report voltage between 0 and 10 volts with 0.9 volt precision. Here are some of the slides. Most time I'll spend on the time. Basically, the first 2 bits, they define whether we are talking about seconds, minutes, hours, or days. And the remaining 6 bits define the number. So example, if I see a bit number which is 4f, it's in hex, it's 4f, for f. So the first 2 bits, it's minutes because it's 0, 1. Then the 0, 0, 1, 1, 1, 1, 1, that's the number 15. So basically it means 15 minutes, and we are encoding it within 1 byte. And that way you can encode up to 100 seconds, up to 100 minutes, up to 100 hours, or up to 63 seconds, 63 minutes, 63 hours, and 63 days, because we are limited by the 6 bits, and 6 bits give you only 63 values. So 63 is the limitation. I hope this is clear. We have again API 6 explain again, and we can give you more examples if needed. And we are using simple time encoding, how we call it. We are using it for most of the values. We are making exception, I think, only for some values where we are using milliseconds, but for 99% of all the values in API 6, we are using simple time. For temperature, we are using again 1 byte, and we are basically shifting it, where we are starting the temperature at minus and at -40, and we are increasing it by bit for each half degree. So we have 256 values. So it basically gives you this kind of 128 degrees resolution that can be reported. And then for the voltage, we are using the classical one, where we are using the bit 30 defines the decimal number, and 664 defines the whole number. Again, it's in the API 6. And here is the example. So, and now we'll get to the most, probably the most complicated part of it. That's the device control. How you can control a device where you have only 8 bytes. And we construed a pretty, I think, unique, or at least we haven't seen it before, a unique way how to control the device, how to configure the device. And the idea behind is that we have a predefined register, so that we have like a predefined database within the device, and each of the cell of the database is prefilled with some value, and every cell of this database has a pointer, an address. And through the downlink, we are basically sending always the address, the pointer of the cell, and the new value that should be overwritten. So within one downlink, we can send 4 pairs or four pairs of addresses and values, and you can change in one downlink. You can change 4 different bytes. It doesn't seem to be a lot, but in most of the use cases, you just need to change some threshold, or you need to change a mode, or you need to change some kind of behavior. Normally, you don't need to configure all 256 bytes. And we have seen that for most of the configurations of the devices, it fits into 1 or 2 bytes maximum messages. Is a mode switch? Okay, that's we'll get it to the mode switches later on in another slide. Basically, when I want to switch from the classical press me to the temperature monitoring and send the alert to 0, it takes me only 2 bytes. I'm sending register 1D, which is the temperature threshold A, to value 50, which is 0 Celsius in simple time encoding. And then I'm sending register 01 to the value 11. So register 01 is the mode, and I set it to the value of 11, which is the temperature monitoring mode. So basically, I get from the dump button, I get a temperature immediately out of the device. So then it leaves 2 more bytes to other settings as appended payload or heartbeats or whatever you need to set up on the device. It's important to understand that in the device we have, as I told you, we have this 256 predefined registers, and we have 2 ways how we change them or how they are predefined. The first one is the factory default registers, how we call them. So those are the registers that are default for all the modes, for all the logics, for all the business rules, and they are always there. Of course, you can write them over through downlink, but they are predefined in the device. And then when you switch the device to another mode, each of the mode contains not only the business logic, but it also contains so-called deltas. So basically changes among the mode-specific values and the default factory values. So when I, for instance, switch from, let me give you an example. When I switch to the read sensor mode, it automatically changes the temperature monitoring mode. The default value for temperature monitoring is don't monitor temperature, but when I switch it to the temperature monitoring mode, it gives you, it starts to sample the temperature each 5 seconds or whatever is predefined in this delta. So that's important to understand that the mode delta, they override the factory values. And also when you switch between the modes, you switch basically to another device. So whatever custom configurations have you done to the device are erased, and you get a fresh brand device. So when you switch, for instance, the mode into the press me mode, you will get it as the same status as you received it from the factory. So you are not able to permanently record an information between mode changes. It's like a reset. Then we have how to trigger downlink request. You can trigger downlink request by several ways. You can trigger it by extra long press when you are holding the button longer than 6 seconds. You are able to do it by heartbeat. So you can configure the heartbeat to request a downlink request. You are able to set it up by alerts configuration. And it's beyond the scope of this webinar. Basically, when you have a security door SimplePack, and there's an alarm, so automatically the alarm can trigger a downlink and can request: should I turn myself off? Should I disarm? What should I do? So some of the events are able to trigger automatically downlinks, and then we have the downlink chaining. It's there because when you want to change when you need multiple downlinks for device configuration, you are able to request another downlink just from the previous one. And the idea is basically it depends on how you sort the addresses how you sort the numbers in the addresses, how you sort it in the downlink message. So when it's sorted in ascending order, the device will request another downlink chain. If the downlink payload is in descending order, no downlink request is sent. Again, please refer to documentation. We have a safeguard there. For instance, if you do the downlinks through the manual direct downlinks directly through the Sigfox backend, it would and you do it in a wrong order, it would request downlinks forever. So we have a safety feature there. When we see that a second downlink is the same as the first one, we are cutting down the chaining ends. So you are not receiving them forever. Heartbeats are special types of events that are outside, independent of the modes, so they work across all the modes. We have two kinds of heartbeats. We have two types. You can set up two heartbeats. They are always time triggered events, so they are triggered by time. You can append messages. You can request downlinks. You can do a lot of things through heartbeats. And then we have also a third heartbeat 3, which serves for the setting timing for the stupid mode 1, stupid mode 2, and max sending modes, for the location things. So heartbeats are very universal. You can achieve a lot of stuff, lot of use cases just using the heartbeat, and they can run at the same time. So for instance, you can have a heartbeat one set each 6 hours with temperature, and then you have a downlink request each 24 hours with a downlink. So this is pretty flexible. We have some useful registers. One is the debug register. Basically, it gives you when you send this FE plus the addresses, it gives you back the values of the current registers, either the factory default ones, or it gives you back your custom settings that you recorded to the device. So you can basically read the values that are recorded in the devices through this register or through this downlink. Then we have the power. You can control in the cases where you have really good Sigfox coverage and you want to save battery life. So you can limit the voltage and attenuation. You can play with attenuation of the transceiver, and you can limit the output of the transceiver, and you can achieve even higher battery consumption, especially if you need really more than 30,000 messages. Then we have a couple of registers from where you can read the hardware configuration and firmware configuration. Those are the only registers that you cannot write into, read-only registers. So, but you can get from those, you can get the hardware configuration, what's inside the device, and the firmware revisions. And again, I'm not going into big details about that one, but for the international version, you can set radio zone, so you can switch from radio zone 1 to radio zone 3, or from radio zone 2 to 4, 5, 6 to whatever. And we have also a specific register where you can set the time, or change the time zone within a predefined time. So basically, when you know that you are shipping a parcel from Europe and will arrive to US within 4 days, so you say, please change to RC2 within 4 days, and the parcel switches to RC2 within 4 days. Will be also the same will apply for Monarch. So for Monarch, beacon sensing will have a predefined time where you'll be able to instead of directly switching the radio zone, you'll be able to start sensing for the Monarch. We have some registers that you can totally switch off the LED. You can switch off completely the button. Be aware, because if you switch the button, it would be a little bit complicated, and you don't set up the heartbeat with downlink request. It will be difficult to get a downlink. So you can a little bit break the device if you switch off completely the button. You can switch off the buzzer completely. You can control the light periods and button behavior. So there are a lot of settings regarding for how long you can press the button, what the different periods for double clicks, long press, short press are. So there's a lot of flexibility here. Currently, you cannot dim the light. We are working on a solution of being able to dim the light, but in the current version, you can just shorten the period for which the light is on, so the timing is completely configurable. Arming and disarming. We are using for most of the modes, with the exception of the button press me mode. We are using a process or a state of devices that we call arming and disarming. You must understand that the device is on all the time, so we are not switching off the device. So the device is, even when we ship it to you in the press me mode, it's still sensing. It's still on, even it's sleeping most of the time. So, but it's still on. So basically, arming and disarming, it does that. It starts the process of measuring and evaluating the measurement. So when you switch the device from press me mode to temperature monitoring mode, it first there's an arming, then there's a departure delay. It can be zero. It can be immediately, and you have the arm state. And in the arm state, the device is sending data, is processing the temperature, sending data, and then you have a disarm where you can basically not switch off, but switch off the device, but switch off the measurement. And there are again multiple ways how to disarm. Normally, we are using the long press event, but there are many more ways how to disarm the device. Currently, you cannot switch the device completely off. There's a kill bit prepared. So for the devices, especially for one-way tracking, where you want to be sure that the device is completely turned off, there will be a kill bit in the future. Some of the registers seems to be misbehaving. We'll have to expand the documentation on that one. But we have like a general settings for the accelerometer and magnetometer sensitivity in multiple axes, and this register behaves such a way that that when you override this register, it overrides the three axes of the magnetometer and accelerometer data. So it overrides it, and itself it gets to 0. So don't be confused when you write a general setting for the magnetometer and the value is not there. It just transcribes through to the specific values of the axis, and then of course you can fine tune the accelerometer, the sensitivity on the different axes of it. That's something that we have added recently. It was on the request of T-Mobile, and it was a large logistics project. We are able now to report light logistic events, device inclination, and temperature threshold in all the modes. So you can have it in the press me mode, for instance, and when there's a temperature threshold change, it would trigger an event. So for those cases where you put it into the box, you want to monitor whether the box was inclined, not inclined, whether there was any bump into the box when the box was opened. So everything is now available, and the firmware supports many parallel events monitoring, parallel sensors monitoring during transportation. We have a very nice case with the yogurt monitoring, where the yogurt needs to be upright and they cannot get inclination more than 20 degrees. Otherwise, the yogurts get spoiled. Please be aware, we have two places where we keep changelog and firmware releases. We have one which is the little bit more public or a little bit commercial one. It's at the URL that's listed here. The firmware release notes, where we are adding what's new and what's fixed, and then directly as the API 6 table on the first tab, we have a very complete changelog for whatever happens in the API 6. So you don't need to track the changelog in the API 6 because it's very technical. But if you want to be sure that some of the features that you are looking for are supported only in some firmware releases. Currently, the firmware cannot be updated via the year. We are working hopefully for next year for a solution for that one. But if you need some features that are supported only in the new firmware, you need to get new devices. There are some things that are not covered in this webinar. We are not covering alerts, which is type of special settings for events. We are also not covering how to set up 103 frame sending. We are not covering that we are supporting 600 bits per second encoding for RC1, and that's the advantage of combining one frame and 600 bits per second RC encoding. It's that basically instead of sending 6 messages per hour, you can send 18 times more. So you can send basically 120 messages per hour, which can be, in some use cases, it can be important, if the dog gets lost. So you need to get more messages. If you need to track some equipment within a courtyard, sometimes you need more messages per hour. So we are able to support 120 messages being completely legal and completely ethic compliant. We're also not covering most of the modes because we have 60 modes. Probably we will have a new webinar regarding just modes for logistics or for some of the specific use cases. And again, I said that we are also not going to tell you how to send the 120 messages. It's not that complicated. It's described in the API 6, but it is beyond just the scope. We are already a little bit late, so there's a demo platform which is called IOFrogcom. It currently supports like 99% of all the functionality. So if you don't want to play with the interpretation of the data, if you don't want to play with the Sigfox backend, everything that it's on one click. It's clickable. You can control the devices. You can interpret the data. You can do the map visualization. There's a 3 months free trial period, and you can of course use your own connectivity. And also it's a new feature that you can use IOFrog as a middleware. So if you just need a platform for interpretation of the data and you want to do your own processing and data visualization, IOFrog supports acting as a middleware between our devices, Sigfox backend, basically between Sigfox backend, our devices, and your own data processing or visualization platform. So we are concluding. When we construed API 6, we wanted to ensure that all the future devices will be forward and backward compatible. So we don't plan any major changes in the API 6 for at least a couple of years. So we want to be backward and forward compatible. It gives us ability to use it in all the devices that we are planning. So, for instance, it's in SimpleTab. We are using the same API 6, the SimpleLeak, the leakage detector using precisely the same API 6. SimplePacks, they use all the same firmware and all the same APIs. So you don't need to develop your own parsers for each of the devices. What I think is pretty important is that you can fine-tune and do precisely fine-tune the device for any kind of POC or for any customer within hours. And what's even more important is that you can use for POC the same device, proof of concept, you can use the same device as you do for the field deployment, because for many of the proof of concept what we have seen is that there's a huge gap when you use something different for proof of concept and something different for field implementation. So I think it's crucial that you use the same device for POC and for field we'll It's also rather easy to implement to any IoT platform. We have currently support of five different IoT platforms. We'll be putting the list shortly on our web page, which hasn't managed yet. And we have achieved integration. There's a big integration with SAP. There's an integration with Azure already, integration with Google, Salesforce, Watson. So the major platforms, they are able to support API 6 pretty nicely. And that's all, basically. You are also welcome to subscribe to some more webinars coming. The next week will be about the IOFrog, and then we'll be doing a little bit less technical trainings and a little more sales oriented and discovery oriented trainings. Thanks for your attention. Now I'm a little bit past time, so I'm sorry to keep you that long. But it's API 6. We have been developing it since 9 months now, so it's a lot of work behind it, and I'm open to your questions now. Or any comments. Thanks, Bart. Thanks, Tafadzva. Thanks, Krolis. Okay, Leroy. And again, we are. If you give us feedback, I would appreciate it, because that makes us. We try to do it for profit, but we are enjoying what we are doing. So if your feedback is the most valuable thing that we can have. Okay. Well, thanks for the praise. That's always nice. Also, if you would have some more ideas what to do in the next webinars, please let us know. You can also we have a chat on our web page. So if you go to our web page, you want to chat with the support or with the sales team, you are welcome to do it. Okay, thanks, Pavel. And I hope you enjoyed it. I hope you will enjoy the devices. The Monarch support is coming. We are working on it. Basically, it's implemented. We are just fine tuning it, and also the certifications are now done. It's class 0, so it's ready to be implemented. Do you plan to provide standard code without updates to deserialize easily the uplinks? I need to talk to. It's a little bit too technical for me, Clovis. I'm sorry for that. One of the things that we want is to have a serialized version of the firmware of the API 6 description. So that's something that we want to have in the future. And is it the role of IOFrog? So basically, IOFrog can do is that they can interpret the data. So if you want to get directly GPS position from the devices without having to interpret the data, if you want to get the vibration directly, so they are able to do the parsing and they are able to do the data interpretation for you and basically push you already the describe and the full data. So that IOFrog can do that. But okay. So thanks for if you have any more questions, you probably know my email address, but I'll be putting it here. So send me an email. Also, we are currently looking for some testimonials for our webpage. So if anyone would want to volunteer to be quoted on our webpage, please drop me a line and I'll connect you to our marketing. So we are looking for testimonials. Thanks, Victor. Oh yeah, I have been doing a lot of stuff based in Czech Republic and Central Europe. I've done projects in Slovakia and Ukraine, but never done a real international one. So it's nice to see people. Currently, we have people from around 20 countries in the world. So people from Japan, people. We are on the different time zones. So if there are no more questions, if there are, so please send us emails, send us a chat, and enjoy the devices, and see you next week for the presentation about the IOFrog platform.